Hello, honors pre-calculus students, Mr. Grisato. If you look at this function, the goal is to graph these functions without a graphing calculator. So you should be able to look at the denominators and realize that x equal 5 is one vertical asymptote and x equal -3 is the other vertical asymptote. The other thing we want you to recognize is since this exponent is a 2, they're going in the same direction. And for the other asymptote, the multiplicity is 1, so they're going in opposite directions. If I were to multiply this out, I'll get -5x squared plus some other terms, divided by x cubed plus some other terms. So when I find the limit as x goes to infinity of the function, I will get 0, which tells me the horizontal asymptote is y equals 0. For the x-intercepts, we look at the numerator. So one x-intercept is 3, 0. The other x-intercept is 2, 0. And to find the y-intercept, we're going to find f of 0, which is -5 times -3 times -2. Divide by 25 times 3. You can see we could reduce, so the 3's reduce, the 2 negatives, or the 3 negatives become a negative, so you have -2 divided by 5. So the y-intercept, I believe, is -2/5, and I'm just going to double check my calculation real quick here. So when I go to graph it, I'm going to graph the vertical asymptotes, x equal 5, x equals -3, the horizontal asymptote is on top of the axes. And then the x-intercept, 2, and it goes through, and 3, it goes through, and the y-intercept is -2/5. So with this information, I should be able to sketch the graph. If you need to do the left or the right-hand limits, you can. In class, we talked about, well, we got the most information around the middle, so let's assume for a second it starts here and comes down and has to hit that y-intercept. In doing that, I just created a x-intercept, which I'm not allowed to do, so it cannot start up there. I know the graph has to start at the bottom. It's going to hit the y-intercept. It's going to go through this x-intercept, goes up a little bit, not sure how high, comes back down, hits that x-intercept, and then goes back down. Now the multiplicity for the vertical asymptote x equal 5 is 2, so I know the graph starts at the bottom and goes up towards that horizontal asymptote, but does not cross because there's no x-intercepts. The multiplicity for the x plus 3 factor is 1, so I know it starts at the top, since it's odd, comes down, and approaches the horizontal asymptote. Let's take a look at the next problem, number 5. Okay, so looking at this problem, again, if I were to multiply it out, I'm going to get -3x to the 4th plus some other terms, divided by x to the 4th plus some other terms. So when I find the limit as x goes to infinity of f of x, I'll get -3. So that tells me the horizontal asymptote is y equal -3. So I'm going to draw that dotted line here in red. The vertical asymptotes, I'm going to get those from the denominator. So x equals -5, x equals 4, x equals -3. The multiplicity on this factor, x plus 3, is 2, so they're both going in the same direction. I may use that later on. So I'm going to draw the vertical asymptotes. We've got x equals -5. Then I have x equals -3. And then I have x equals 4. And then for the y-intercept, I'm going to calculate f of 0. So negative 3 times 4 times 1 times negative 3. Divide by 5 times negative 4 times 9, which I'm going to write as 3 times 3 because it's easier for me to see the reduction. So f of 0 is going to be negative. When I look at all the negative, the 3's reduce out. The 4's reduce out. So assuming I do this math right, I get negative 1/5. Please check my math. So the y-intercept is negative 1/5. Let's say that's that blue dot. The x-intercepts are going to be negative 4, negative 1, and positive 3. For this factor, x plus 1 squared, it's just going to touch at negative 1, 0. So since it just touches at negative 1, 0, there's no way the graph could start here, come down, touch that y-intercept, bounce back up and get down to the, touch that x-intercept and then get down to that y-intercept. So I know the graph has to start down at the bottom here. It's going to go up, touch that x-intercept, go through the y-intercept, goes down, and then the multiplicity on this factor for the 3 is 1, so it's going to go through 3 and then keep going up towards that asymptote. Now I'm going to use the even and odd multiplicity. To the right of 4, the exponent is 1 here. So it has to start down at the bottom. Now let's assume you thought it started at the top and came down and went towards that horizontal asymptote. Well, you just created another x-intercept, which is not allowed. So the graph has to start down at the bottom and approach that horizontal asymptote. Now to the left of negative 3, we could find the limits as x approaches negative 3 from the left, which means I'm plugging in like negative 3.000001. So I got negative 3 times a positive times a positive times a negative, divide by a positive times another positive, negative for the x minus 4, times a positive, and that number is small. Remember, when you square, you get a positive. So multiplying this out, this is going to go to negative infinity. And that matches up because the exponent on the x plus 3 is 2, which means it has to start down at the bottom, go through this x-intercept, and then keep going towards the top. And then the asymptote x equals negative 5, the asymptote has a multiplicity of 1, which means it also is odd, which means if it starts at the top over here on the green, where I just highlighted, it has to be down at the bottom. So then this would be a reasonable sketch for problem number 5.